Okay, so we're solving radical equations. Like I told you guys, this assignment, this lesson, this set of concepts, which is pretty thin actually, is going to be key to working on the quarterly extra credit assignment, which will happen right after quarter 3, be around spring break. Okay, the solving problems related to E equals mc squared and Einsteinian physics. So, what is a radical equation?
An equation that contains a variable within one or more radicals.
So what's that mean? What am I talking about radicals? Can you guys refresh my memory? Like what? What are some examples of radicals? Square root, or cube root of x, or fifth root of x plus 5. Now if it's just the square root of 7, then there's no variable in there, so that's not necessarily a radical equation. I'm talking about stuff where the variables are locked inside of radicals, and we got to get them out to solve the equation. Does that make sense? So I think each one of these qualifies. These are all like Algebra 1 radical equations that I'll be solving with my class later this year. So let's review. How does this work? I think there's a process, so maybe we'll, in the top right corner, write down the process here in a sec. Any ideas? What would we do to solve for x here? You guys give me any ideas? I'm not telling you how to do it.
You need to pull the x out of it.
I need the x out, but like think about solving for x just like you would any other equation. Usually like move stuff away from it, right? So like the 2, what should we do? Divide. Great. That's, I think what we should do first, if we're trying to move stuff away from x, and if our goal is just to move stuff away from x, like any old equation that we've seen in the past, there's more stuff there. There's like 2 things, right? There's the +1 thing and there's the square root thing. So which thing do you think we probably need to move first?
The square root.
The square root thing, because the +1 thing is locked inside with the x. It's stuck inside there until you get rid of that square root. So the question is, how do you get rid of the square root?
Square.
You square. That's the inverse operation. Totally. So if you square both sides, that gets rid of it. It cancels, becomes x plus 1. Over here you have 49, and now of course you can subtract your 1. Get your answer. Yeah, I mean, this one's simple enough to where you could just like guess the answer right away, I guess, almost, right? So yeah, you can totally do it that way, Kosh. But they're not all going to stay this easy. Yeah. Okay, so second one, what do you guys think? Subtract 5.
Yeah.
And then, what is that, 11? So, square it. I like to put parentheses around it because that's going to matter when we get to some tougher ones. And subtract your 1. So we have a cube root. I don't think things change a whole lot. What should I do first? Divide by 11. Divide by 7. What do I have there? Really? 70 is 10 times, right? It's 12, yeah. Jeez. You're not coming off too well in this video, Akash. Wow, we're live.
We're live.
Okay, so, then, how do I get rid of cube root?
Cube it?
Yeah.
Wow.
This is rocket science, right? 12 cubed you might need a calculator for. It's 144 times 12. I don't feel like doing that right now, so yeah. You guys help me out. Thank you, Noah. Okay. And of course it's just a little linear equation from there. So I need to add 7, is that 35? And divide by 5. I don't want to divide that by 5. Please help me. Please help your poor math teacher.
It's 347. I got you, Montana.
Okay, so there's solving some rather simple radical equations. I think those are all Algebra 1 problems, whether you did them in Algebra 1 or not. Okay? So let's see if we can look back at them and develop a process that then we can kind of stick to when we look at some tougher ones. I'm thinking that's what we should do. So, what do you guys think? What is the procedure when we think about what's like the first step you need to do? What do we do on each problem like the first step? We moved something away from what? Away from the radical. So we got the radical isolated. Very nice. I like that. We got the radical by itself, yeah? So step one, if you want to make this into a process for yourself, I like Noah's word. That was the one I was going to use. Pretty nice. Isolate whatever radical you have. You need to get it by itself. Now we're going to see problems next where we have sometimes more than one radical. Well, I think in that case you need to pick one of them. I don't think it matters which one, and isolate that one. Okay? So pick one and isolate it. But get one of them by itself, okay? Step two. What do we do next? Once it was by itself, we
get rid of the radical.
We got rid of the radical by doing what? Squaring it or cubing it. So let's I'm gonna use what Sam said. I'm gonna say get rid of the radical, and then I'm gonna use some vocabulary. Here's why you need vocabulary. Get rid of the radical by, let's say, operating with the appropriate power. I don't have to use much vocabulary there. On both sides. So operate on both sides with the appropriate power. The power, in fact, that matches the index of the radical, right? Use the inverse power. Okay, and then I think it really depends what's left at that point, so I'm going to help you guys out with the third step. I think we're going to see things that do different things at the end. So let's just say simplify or apply other ideas to finish solving. Because on these, so far, we had a linear equation left in each case. I don't think we're always just going to have a plain old line left in each case. Okay? All right, let's look at some tougher ones. Okay, here we have a couple more radical equations. So let's kind of use our process to guide us. On the first one, how many radicals? Two, so we get to pick which one we isolate. Is one of them isolated already?
Yes. No.
Yes.
Yeah, which one? The left or the right-hand one? Left-hand one's already by itself, right? So let's skip to step two. Step two says, do what? Cube it. Yeah, get rid of it. This time we're going to cube it to get rid of it, right? So cube both sides. Notice I'm cubing all of both sides. You must do it that way. If you don't, there's going to be opportunity for mistakes. So here's the mistake that a lot of people are going to make. A lot of you are going to make it if you're not alert. Where's my mistake? I didn't cube the 2. Why do you need to cube the 2? Because it's part of that side, and we have to cube all of both sides. If we do something to one side, we have to do it to all of the other sides. Does that make sense? It's clearly inside the cubed here, so you clearly have to cube it. So instead of 2, what should really be there? 8. So if you have a 2 there, you're going to be wrong. So I'm telling you, be careful with that. Because I see people do it every year. So now I think we've got a little linear equation, right? Simplify to solve. I'm going to distribute here. You do your favorite linear thing. So then I'm going to subtract x. I'm going to add 8. And I'm going to divide by 2. Boom. Done. You know, one thing that's been weird here is I haven't been checking my answers. When I was your age, my teachers were really big about that. They were like, you always have to check your answers. And I, being the rebellious, normal young person that I was, never checked my answers because I got really frustrated. I'm like, I'm done with my math homework. I'm done. I'm not checking my answers, you know? But I think this is a complicated set of equations in some cases. So I'm not going to tell you to check your answers every time. I'm going to tell you to be a little bit aware. So let's not worry about it on this one. We'll just accept that that probably works. Nothing too fancy happened. Let's try the next problem. So you guys, what's step 1 again?
Isolate radical.
It's already by itself. Okay, next step. Get rid of it. Peel it off. How?
Cube everything.
Square.
Oh,
We gotta do to everything. You're right, Jensen. So on this side we've got x plus 18, and on this side we go x squared plus 4. Yeah?
yeah.
You guys believing this?
No, not.
Oh, because you just like put a plus in there. Right?
This is one of the worst mistakes you can make in all of algebra right here. I think this is number 3 on algebra mistakes of infamy, or number 2, I don't remember what we called it.
Crap.
You can't just square both things and distribute that if there's a plus or minus in between. I hope you remember. This is really what? So yeah, there's an x squared. Yeah, there's a 4. There's like more stuff, so don't forget that more stuff, or you'll be repeating algebra long into the future, and that will be unfortunate. So we've also got a negative 2x and another negative 2x. I think we've got a negative 4x going on too. Okay, so make sure you expand binomials. If you end up squaring or cubing them, you better cube them and use Pascal's triangle or cube it out the long way, whichever is your preference. Okay, so that was almost disaster. Okay, so this time we don't have a linear equation left. What kind of equation do we have left? Quadratic, for good. We've got a parabola left. So parabolas, we pretty much always set them to 0 to solve them before we use the formula or factoring or whatever. So I'm going to set it to 0. Show my work a little bit. So there's 0. Got x squared minus 5x minus 14, is that right? Okay, so you should always try to factor something that's a parabola before you go ahead and use the quadratic formula. Is this thing factored? Yeah? I heard it. 7 and 2 specifically. Guess we could get it going. -7, +2. That adds up to -5, multiplies to -14, boom, yes. The reason we factor is because like the zero product property thing that says if either of these is 0, the whole thing's 0. That's why we set it to 0 in the first place, right? So if I plug in 7, it's 0 times stuff. So 7's an answer. If I plug in -2, it's 0 times stuff, which is 0. So -2 is an answer. That's why we factor, remember. So those are both answers, right? Well, sometimes radical equations do have 2 answers. It depends, though. Let's think about what the graph of this would look like. I don't even think we need our graphing calculator. You could, of course, use yours. But these are pretty simple things to graph. We just learned how to graph root x plus 18 last section. Where's that plus 18 scooted? Left 18, right? So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay. Somewhere over there. You guys got me? What kind of shape we got going on? Good? We've got a shape slowly growing square root shape. This, what is x minus 2? Remember, we're ignoring this blue stuff.
Shape of life.
That's mx plus b, right? The line. Y-intercept is -2. Slope says go up 1 over 1. Okay, you guys look at this picture and tell me how many answers you think there are to this problem.
2. Well, no, it's only across the line.
There's 1.
Yeah.
It's that one. Which one of those answers do you think that one is? Just guessing. It's the 7. Clearly, it can't be the -2 because that'd be over here. Do they cross at -2? Clearly not. So this guy is an extraneous solution. So, does that mean you have to check every problem when it's a radical equation? If you're my teachers, then yes, but then you hate math, and that's not good. We don't want to hate math. We want to like mathematics. So there's always a better way to do things. So to avoid extraneous solutions, do just what I told you to do with logarithms. Just quickly think about your answer in the context of the problem and see if it might make sense. You know what I'm saying? So if you get two answers, you should be a little skeptical is all I'm saying. There might be two answers. Do you guys think that there's a way you could make a line like that cross that thing twice? Think about that visually. If you could move that red line, is there a way to make it cross the blue curve twice? You have freedom now.
Yeah, there is.
Yeah, could we take it and grab it and like make it go up here, something like that?
Yeah.
Then it'd cross twice. So it's possible to get two answers, but with these kind of shapes, do you think you're going to get two crossing spots very often?
No.
So no. I mean, is it possible to get no crossing spots?
Yes.
Yeah, you could take the line and go like, make it like y equals -5, and then it would have no answers. So that could happen too. So that's why you got to think about stuff. So just toss these back in real quick. If you put 7 in, you get root 25, that's 5. 7 minus 2 is 5. Yes, that works. If I put -2 in, square root of 16 is 4. -2 minus 2 is -4. Is 4 -4? No, there's proof that that doesn't work. Okay, but if you think about the picture and you use all the knowledge that we've been gaining together, you can make this a streamlined process rather than just some arbitrary, boring procedure. Okay, so that's the way you should be shooting for. Let's look at another one. Okay, so if you're watching the video, I'd recommend pausing it right now and working through this problem. It's almost identical to the last one. So for you guys, let's see, first step, it's already by itself, right? So we can square both sides right away. Squared cancels square root on this side. And we expand this binomial on this side. That's the way I think about that. There's no plus, if there's a plus or minus, you better be thinking expanded. So the shortcut formula, if you know it, says square the first thing, square the last thing, negative squared to positive, and take 2 times the things combined. So 2 times 5 times -x is -10x. There's the fast way. If you want to write it out twice, as many of you will want to, then write it out twice and FOIL it or whatever. Okay. It's a quadratic, so that means I need to set it to 0, so I'm going to move these guys over there. You can move stuff wherever you want, but positive x squared's over here, I like it. Being positive, that's easier to factor. Yeah. So I'm going to say x squared, I'm going to add 3x, so that's going to be -7. I'm going to subtract 33 on both sides. So, -8. Okay. Factors of -8, well, we got 4 and 2, 8 and 1. Those are factors of +8, I should say, but I think we want, what, 8 and 1?
Yeah.
-8. +1? Yeah. Okay, so our answers are, shouldn't put equals there, I should say x equals 8 or x equals -1. So we could go visualize it as a graph again, but let's pretend we're really pressed for time. Do these both work? They could. Check them. So if I put in 8, -24 plus 33, is that 9? So that says square root of 9, that's 3 equals 5 minus 8. Is 3 equal to -3?
No.
So that doesn't work. He's out. Check the other one real quick. If I put in -1, I get the square root of, do a little more work this time, 36. -1 minus a minus, 6. Check. Okay? So, there you go. Let's look at this one. So, how should I handle this one, guys? Why is this a radical equation? I don't see any radical. Where's the radical? It says it's in the radical equations section. What's this?
Oh, that is.
Remember, half power square root, third power cube root 2/5 power 5th root of stuff squared. Yeah? So, really this is just another equation like we just did. Radicals by itself, get rid of it. Four x squared. See, the 4 is the part you guys are going to miss if you're not alert. Cancels out. Oh, it's a parabola again, darn it. There's nothing that says when you're done with this you have to get a line or a parabola. That's just the kind of problems that you have in general. There might be something with like an exponential or something. I mean, anything could come up. Just depends what problems the author has cooked up for you. This guy, to factor, I'm going to do what first? This one, I think I should do... I'm going to divide by 4. See, dividing is not a very good way to work with stuff later on, though. So, like, I want you to get that out of your head as, like, a good way to do this problem, or you'll lose answers later. So, what's another way besides dividing by 4? Factoring's a much better way to do things. They share 4. You guys saw that when you said divide by 4, right? It's better to pull out things that are shared, because then this is directly equivalent to this. And you don't have issues, some of which lead to this extraneous answer coming up on this other thing. So I'm talking about a higher plane of mathematics, but if you just get in the habit of not dividing, instead factoring, you won't even have to think about that. Okay? Does this one factor? I'm hoping. I mean, it might not. 2 and 1s are only choices, right?
Yeah, it's a -2.
I think it does. Sweet. So that product is 0 when x is 2 or when x is -1. I'll leave it to you guys to check. I'm guessing probably only one of those works. They might both work. They might neither work. Depends. Okay. Okay, so let's look at an application where we're solving radical equations. So this one says a car skids to a stop on a street. The street has a 30-mile-per-hour limit, speed limit. And the cops went out and measured the skid marks, and they know that this kind of pavement, each kind of pavement has a different coefficient of friction. Like when they put sand on it in the winter, that really changes the coefficient of friction. There's all kinds of ways to change that. So they measured the physical properties of the pavement, and they got 0.7. This is, by the way, the static friction coefficient. So what we want to know is, was the car speeding? This is actually how cops do things. Yeah, so maybe there was an accident and the cops want to know, was this car going 30 miles per hour above? Were they going 60 miles per hour? And then they're really going to be in trouble and probably get like a misdemeanor offense, something like that, yeah? So this is the kind of thing you'd use in criminal science. So it's not like you, as the student, are expected to know enough physics to come up with this, the main equation. You're given that in all the problems in here. And there's some good ones. There's ones with like the Fujita scale for hurricanes. There's some interesting problems in this section for sure, some actual real ones. So please take them seriously. They're pretty neat. You're given this. This you have to know a bunch of physics to come up with, yeah? You learn about that in a more advanced course. All you're doing is they gave it to you. Now, they're going to tell you what the letters mean in all your problems. Let's see if we can use context clues here to think about what these different letters mean. What do you guys think the S means in this situation?
Speed.
So this is how speed relates to, and what do we think the F and D mean? F is the friction coefficient, which in actual physics, this is static friction, so in actual physics it wouldn't be that, it'd be mu sub S, if you like trivia. And what do you think D means?
Distance.
The distance of what? The skid mark that they go and actually measure with a tape measure, yeah?
30, always be 30.
Yeah, so for some reason the physics says that 30 is always 30. So we'd have to get into the physics. So for this one, yeah, 30 is always 30. I don't think it's the same 30 as the 30 miles per hour. That's weird in this problem, isn't it? So yeah, good question, Bryson. Very good question. So I think this has to do with the properties of this kind of physics, not with that 30. Great question. Okay, so let's plug in our numbers and see if this car is speeding. So what goes where? Well, F goes for friction, so 30 times 0.7, right? And then D is what? 35. And we really want to figure out how fast the car was going so we don't know what S is. Now, on your problems, you could have an unknown here, you could have an unknown here. It just depends. I mean, you should be able to solve. This one, it's already solved for, so we can just stick it right in our calculator, right? So on this one, we can just say, all right, can you guys stick that in your calculator and see what you get for the speed? It's an S, not a 5. What do we get?
27, 25.
See if you can agree with Michael. 27.11, and make sure on all these problems you get your units. Speed in this case was, I think, miles per hour. There's a whole lot more to the units issue, but we're gonna set it aside. So is the car speeding?
No.
No, boring. Let's do another problem with this same thing. So let's say we have another car, and the skid marks measure
50 feet.
Let's go for something more. 80 feet. Let's say 80 feet skid mark.
50 feet.
And let's say we don't know what this coefficient, what the coefficient of friction was, because that's the thing that's hardest to measure in this situation, I'll tell you that. Let's say we want to know what is friction. But we've got a radar gun, because almost everybody that's a cop has a radar gun, and we measured and clocked this car, and it's going 50 miles per hour. How are we going to find F? Well, use the same relationship over there. So now we've got 50 for S. 30 goes here. We don't know friction. We do know we slid 80 feet. So now, can you guys help me solve for F?
Yeah, done.
It's the radical by itself?
Yeah.
Yeah.
It's power 2.
So, square it. Yep. I'm just going to put those together. 30 times 80. Actually, you don't even have to put them together. Let's just leave them apart. You don't have to put them together. That's a waste of time. What am I going to do with both of them? Divide. You want to put them together to make yourself feel warm and fuzzy. Then do that. I think if you simplify with your calculator, you're going to find this is 2400. You guys help me as a decimal. And this is an awesome result. I'll tell you why.
1.14.
Here's why this is an awesome result before you guys take off. This shows that the situation I invented here is impossible, because static friction cannot be more than 1. So somebody was lying. The cop who measured the skid mark was lying, the cop with the radar gun was lying, and that would be proof in court that somebody was lying.